and conclude. So just a couple of definitions, 3 things I wanted to mention. First of all, mobility. In the past, we thought about mobility as being a device that can move around. The context has completely changed today. What we're really talking about is the mobility of applications and data and information. So the fact that applications and data can be available on multiple devices in multiple environments. The next thing is consumerization of IT. So this kind of gets confused a little bit with bring your own device. But consumerization of IT is really what happened as a result of the PC revolution and then the embedded devices, which has had an effect that even in data centers today, well, if you look at a traditional IT infrastructure, they're going to have high-end Xeon chips with lots of RAS features, security features built in. The modern cloud infrastructure, because it's MIPS for rent, they're not based on these high-cost microprocessors. They're using desktop and consumer-type microprocessors. So that's what we talk about when we mention consumerization of IT. Okay. Then you've got this other notion, which is bring your own device, whereas in the past we had a mainframe, and the mainframe, the terminal concentrators, the terminals were all built by the same company, and with things like SNA, you were able to completely control the security perimeter. Now we're in a situation where people are bringing their own devices into the enterprise. They want to connect to their email, they want to connect to their calendar, they want to connect into the IT systems, and this is creating a lot of challenges for the IT infrastructure. So as a result of these situations, what we've seen is that the enterprise IT perimeter is expanding. So not only have we got the consumerization and the bring your own device, we've also got this notion of outsourcing. I don't know, some guy in the Harvard Business Review published a thing about core and context. So companies want to focus on what is their core business, their core value add, and then outsource everything that is not part of that. So outsourcing customer relationship management, human capital management, and so forth. So the enterprise IT is now not only controlled internally in the data center, but very important subsystems are outsourced to other companies like Siebel, PeopleSoft, and these kind of things. The other thing is applications are on devices. So previously the applications were running on the IT infrastructure. Now they're running on devices that people don't control, both in terms of devices of their employees, but also partners and consumers. Other issues are access networks, whereas previously everybody was on a corporate LAN. Now they're coming in over Wi-Fi, hotspots at coffee shop, at home LANs, 3G networks, and so forth. And so in that sense, the trust that is required, you need to now do encryption, you need to do a lot more authentication, authorization, and so forth to make sure that the people that are in the chain, in the network chain, going all the way back to your applications aren't filtering off information or learning things about your enterprise that you don't want them to discover. And we also have the evolving hardware and software technologies, and also networking technologies. So progress moves on, new devices come, new operating systems, new types of switches and so forth, all require additional mechanisms in order to make sure that the security requirements are met. And then we just heard in the last talk, companies are more and more basing, in order to automate production and distribution and so forth on RFID. Smart sensors is a big issue coming up. Surveillance cameras, if they get hacked, that sort of stuff. So this is what we talk about when we look at the expanding perimeter of IT. Previously it was contained within the company. Because of all these other vectors, it's kind of spread out very large. So this is, of course, a huge challenge to trying to maintain the control while embracing this evolution. Okay. So here's a cartoon about bring your own device. Let you look at that for a second. And clearly not feasible anymore to control that. So what about the user? So we've seen that the role that a person has at any given time of day or on the weekend, you're going to be doing work-related stuff, home-related stuff, private-related stuff, stuff related to your club or whatnot, and these contexts are blurring. But you want to be able to access all the information and communication technology tools through the appropriate devices that are available. So if you're sitting on the couch with your tablet, you want to still be able to look at your corporate email or send a quick message, check what's happening on the weather, etc., etc. What's important for the user is ease of use. We've got information overload. We've got lots of stuff to do. We also want to be sure that what the applications that we're using and where our the activities that we're performing, they're actually going to be successful or actually lead to something. We also want to control the stuff we own, right? So I don't want the company taking over my phone just because I read my company email on it. Okay, and then of course privacy. For some people, privacy is much higher up on the list, but for many users, it seems to be quite far down. So if we switch over to the CIO or the enterprise IT folks, so what they want to do is manage the cost of business to consumer, business to employee, and business to business application and data delivery, right? So that's his job. His job is also to make sure that by applying ICT, information and communication technology, improves the productivity of the company. Whereas in the past, a huge drive of IT was to make the company more efficient, that is, reduce cost. You had your different workflows, you analyze your workflows, you automate them, you provide tools to make everything more efficient. So this is fine, but then at one point in time you realize that you need to now do some new things to change things. So this is where we want to have more innovation. We need to make the enterprise more effective as opposed to just efficient. In order to make an enterprise more effective, we need to improve the scope of which people collaborate with other people and how they collaborate, and make sure that their collaboration is secure, right, while enabling the innovation. And that becomes a big challenge in and of itself. So securing data and in motion and at rest. So data going over the networks and data that's landing on various different devices. Right. The IT organization also has a responsibility for compliance. So Sarbanes-Oxley, PCI compliance, and all these other things that the different industries have. And of course, they need to be able to do the audits so that they can prove that that they are indeed compliant. And related to what I was talking about in terms of making an organization effective, you want to be able to apply policy to individual users, to groups of users. You want to apply policy to applications, different applications, and also to apply policy on different devices and the types of devices. And when we talk about users, they could be employees, contractors, partners, or even customers. So that's kind of the user requirements and the IT requirements. And we'll see now that these are quite in conflict. So this is a visual, attempted visual to show the expanded IT perimeter. So we've got the corporate IT infrastructure, and of course the firewall isn't where it's shown to be. It's in front of each of the sites and so forth. I just didn't want to draw it all over the place. So we've got the corporate IT infrastructure, which is shrinking, right, as they start to focus on their core and outsource stuff. So outsourcing the stuff over here to the SaaS providers, moving some of the compute out into the public cloud, right? These are corporate sites, so some of the sites that have a corporate network access, other sites that don't have corporate network access, they're just connected to the internet, and people will either VPN over, or they're going to use some form of a secure reverse proxy in order to do the protection. Okay, so in terms of what has to be protected, we can see that this becomes much, much larger in the new context. So what have we got in terms of tools to deal with it? So one is what they call mobile device management. So one of the issues is in order to control the device, you need to take over the device. Right? And this is in direct conflict with what we're saying is the user wants to control what he owns. So if the IT wants to control their footprint on the device and they use like an MDM solution, then what happens with most of them, like Afaria and Boxstone and all these things, you download an agent from the App Store. Well, first of all, you download a program that's going to figure out what version of the operating system your device has and what type of device it has, and then it'll tell you which application needs to be loaded for that specific device, right? And what do these things do? Well, they do registration, so you can do self-provisioning. They're also going to do an inventory of which devices are accessing the infrastructure on behalf of which users. Configuration management, it makes sure that only applications that are allowed are put on the device. It will automatically remove applications that are not allowed by the policy and so forth. It can also do remote wipe. It can lock the device. It can also do pin reset. These are some of the things. Connectivity control, particularly nasty one, is that control for online applications. So if the policy is this application can only be used online, if you don't have a VPN connection, the application doesn't work, right? And then all sorts of restrictions. Restrictions on the application, restriction on the camera, and so forth. Now, as we probably surmised from the talks that we had earlier today, you can have a good shot at this, but if you're really determined, you can work around pretty much most of these things. Right? So this is trying to control it from the device side. Another approach is the mobile application management. So instead of taking over the whole device, right, you just have a corporate application, or one or more corporate applications, and the applications have actually got something inside them that allows the policy to be configured and enforced. So there are two approaches. Essentially, one is the application is built with an SDK, and the SDK puts the appropriate monitor points for the policy enforcement and the calls out to the policy decision system. Or, like for example, Mokana, they have a wrapper which essentially takes an existing application and puts a wrapper around it. So if you think about like a libc, okay, it basically stubs out all the entry points and then applies the policy on the trampoline calls through those entry points into the actual operating system. Okay, so what are these things used for mostly is like storage and network encryption. So any calls across the operating system interface with user data, the data is automatically encrypted. It tries to do things like cross-application data protection. So if you do copy and paste, you do copy from the application, you try and paste it somewhere else. It will paste it, but it will have it in base 64 with some sort of tag on it, so that you can send it in the email, right? But only another client that has the appropriate stuff in it will then be able to decrypt it. So you can copy and paste, even if it goes through non-secure channels. If it pops back into the secure environment, it then can be read again. Access control, similar to the device management. This is now the application or the container can wipe any data that has been recorded and so forth if it detects that the device has been compromised. As we saw a couple of talks ago, the jailbreak detection mechanisms can also be circumvented. And then finally, usage control. The app can be controlled depending on where you are, what time of day it is, how long can you use the application for a given period, what sort of connectivity it has, and so forth. So these are just the features that you can find in the 20 or some companies that supply these kinds of solutions. So this is what the IT managers have as tools in order to try and control what happens on the client side, and to a certain extent also on the connection across the different networks to them. So in order to have a look at the different exposure levels, I'm going to run through 7 different client architectures verbally very quickly, okay, and just touch on the kind of security considerations that you have on them. So the first one is remote application delivery. This is like your VNC kind of thing. So you have your Windows desktop application, operating system instance running in a data center, and the screen pixels are being sent over the network onto a player that's running on your device. Keystrokes and touches are sent back to the application. So in this model, all the data stays in the data center, no data goes onto the device, all the policy can live in that data center, and things are just the way they used to be, more or less. The downside with that is it's a pretty crappy user experience, because the if you turn your tablet one way around or the other way around, yeah, the Windows applications running in the server doesn't really take that into account. Companies like Citrix and so forth are trying to mitigate some of these things. So what we're seeing is the VM players and the Citrix HDX, they are moving a little bit more and more to that container model that I spoke about a little earlier on. The second basic approach is your device runs a browser, and this is the Web 1.0 kind of model, and the server, here's your typical 3-tier architecture, data layer, app layer, and web layer. And again, here, most of the control stays in the data center or in the cloud, but under IT management controls. Downside of this, it's outdated, and the user experience is pretty crappy as well, I mean, compared to a modern user experience. The next type of architecture is the client-based mobile web apps. So this is typically what they refer to as rich internet applications. So now we have a split in functionality. The gentleman who talked about the Ruby on Rails, you have this notion of a model view controller. The model view and controller can be distributed in different ways between the back end and the front end. So in the Web 1.0, everything is in the back end pretty much. You only have the view, to a certain extent, the DOM and the rendering on the device. With RIA, you can have the full MVC on the device or some sort of distributed thing. But this requires applications to be written in a much more sophisticated way, because the app is, in a sense, a distributed application. Right? And if we remember, for MVC approach, you want to have a model that's intuitive to the user, right? So that the controls and the views reflect what the model is, so they interact with the model through the view and the control. So this makes the risk surface much larger, and we'll talk a little bit more about it in a moment. And we've got the native apps that everybody knows. There is also a hybrid mobile application. So this is a combo of native and web. So you'll use the web stuff for the simple interaction, and then if you want to do something like stream some secure content or display some secure content, and you don't want to trust the web view or the browser thing, then you have your own specialized native player to show that content. Okay. Then 6 are the container deployed applications. So these guys are a little bit different in the sense that you have a container, and then that container is what you download from the App Store, and that container in turn will go and fetch other applications. So for like Android and some of the other devices, these things can be fairly diverse. People use some languages like Lua scripting language, a very small embedded language, to do that sort of thing. The Apple terms and conditions only allow JavaScript to be used in that context. So that kind of forces you back into the Model 3 over here. Okay. The downside with this model here is that the user experience, as you flip between the container-based applications, you have one model, but then when you want to flip between one of those apps and a real native app, it's like confusing, because it's a whole different look and feel. So the app switcher, the launcher, and all that is specific to the container and generally not compatible with the native system. And then finally, we have what we call client-side virtualization, or running multiple operating systems or multiple instances of an environment on the device. So the resources of the device are divided between what the enterprise can use and what your private use is, right? And we've seen various types of approach, going from the simple dual boot thing, which is completely useless in the sense because it takes a long time to switch from one to the other. We've seen attempts to use like kexec, where you can switch quickly to another Linux kernel and back again. There's even been attempts to use like hibernation, so you have two instances, two operating systems running at the same time in the device, and the one will hibernate and switch control to the other, then that one will go to sleep and that one will start. There are all sorts of issues involved with that. And then more recently what we've seen is embedded hypervisors, and one of the gentlemen that are going to talk later was instrumental in doing some prototyping on that in the context of the work that we're going to talk about. So if we look now to the infrastructure side, there's the enterprise app store. So this is managing the application, so you can do like application screening. So this is using tools like those static and dynamic analysis. You screen the application before you put it into the app store. There's application mapping. This application can only be used by this type of user, etc. Application management, make sure that the application is up to date. If the application is not patched or up to date on the device, it won't run, that kind of thing. There's MDM and MAM, so mobile device management, mobile application management, which we saw from the client side early on. If we look at it from the infrastructure side, you can manage the applications on the App Store. So these are apps that are still in the infrastructure. But then there's the applications that are already on the device that you need to manage. And then there's the applications that are actually running on the device that need to be managed. So that's that part of it. Obviously, VPN tools, a very highly used method. Then there's security gateways. So this is more like the web approach, where you have external entities come in. Everything comes in through to the secure reverse proxy. And the secure reverse proxy then sends the applications to the appropriate back-end infrastructure after having gone through the appropriate policy checking. So authentication, authorization, making sure you've got the right tokens, etc., etc. So this becomes one of the main areas for policy enforcement. So in the same way as the container in the client side is one of, or the hypervisor or the operating system on the client side is a policy enforcement point, for the IT infrastructure, this becomes the key policy enforcement point, right? So if we remember back to that expanding context, you really want to make one entry point, and to the extent that you can secure your infrastructure against the web, and then you use a web model for all your mobile devices, whatever they happen to be, in that same way, you kind of have a uniform architecture. And then if you outsource some function, you don't have to re-architect your infrastructure. Another value for Fortune 500 companies is when they make an acquisition, it's very easy to onboard the acquired company into this kind of infrastructure, as opposed to try and get the two IT systems to interface with one another. And the last thing that's critical here, as we saw, you have different types of administrative domains, people coming from different identity registers. So we have this notion of federated identity management, which is another tool. So there's companies like Ping, Simplified, and I learned about another one, Rockforge, ForgeRock today. So endpoint security challenge is a little bit of a misnomer in the title, but anyway, multi-tenant administration is becoming expected of endpoint devices. This is like looking a little bit into the future. And when we're talking about endpoint devices here, we're looking at rather high functional ones, not smart cards and stuff like that. So to allow IT policy control for just a set of the apps, or just a part of the device, not the entire device. To have like different zones on the device that can be managed by different stakeholders. The protection of the personal device, that I think refers to trusted computing base. Right, so it's going to be like a standard for trusted computing on devices. So that, and this goes to touch on the point that I mentioned about user requirements, is assurance. My device is safe despite the fact I got all these other IT administration people doing stuff on my device. So from the IT manager's perspective, we asked the question whether the feasibility of federated management in this expanded perimeter of the IT space is actually possible. So we've already mentioned new devices with emerging capabilities. We have enterprise applications. These can be private or public app stores. So for the private ones, we can do our static analysis, dynamic analysis, screening, etc., etc. With the public app stores, we've got to rely on the Apples and the Googles and so forth to do the screening. We have to rely on our outsourced SaaS application vendors, Salesforce.com, PeopleSoft, Alia, and that sort of stuff. We've got the issue of public applications, which are not screened and secured in any particular way. How do we deal with those? Do we sandbox them? How easy it is to deploy them in the sandboxes? And then we also want to be able to define these user communities that cover multiple administrative domains. And in order to promote collaboration across these boundaries, we need to have what's called secure content management. So if I share some documentation with Florent, and then but I'm okay with Florent to see that information, but if Florent shares it on to Fabien, Fabien's not in the right security domain, that should be prevented. So how do we deal with this transitive or delegation of authorization issue? And that's not only an issue for data, it's also an issue for applications and services. So if I use a web service, I'm authorized to use it, somebody else uses it on my behalf. How do we deal with all that? This is a huge issue in the industry that we're facing. So finally, in conclusion, I'll just summarize. Corporate IT landscape is expanding. Full control is not possible in most cases unless you put some huge restrictions on everything. The question is, how much control is good enough, or is good enough? In order to maintain IT control, you're going to need to outsource some control. So who do you outsource it to? Right? So these are going to be device manufacturers. Right? There's a ton of crapware on most of the devices that is actually compromising the security that the operating system vendors are actually trying to build in. So Google tries to do a good job, and then the Samsungs and stuff like that put their crapware on and expose all your data again. That's no good. So these guys need to come into line. Service providers and also the carriers. This is the network carriers. Right? They're deploying lots of very clever stuff in their network to sniff out traffic and so forth. How do we know where that data goes, etc., etc. And my final comment is there should just be one web to rule them all, and then we normalize the technology and it becomes a bit simpler. Thank you.
We have time for a couple of questions.